the ABS welded back together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're golden. Hi, I'm Monte, and welcome to the next exciting episode of Coke and Strippers, where you always get the full Monte. And today we're going to build this. While we don't have time to build this entire Cobra, we are going to replace this nasty looking third brake light with a new one. But you know what we say on Coke and Strippers, why be ordinary? We're going to build in some special features, including a Cylon mode. I looked online and I found this piece, which looked like it would be just the perfect thing to convert. It's kind of hard to tell how many actual LEDs it had inside of it, though. Let's take a look and see what we got. You couldn't really count it. You're supposed to connect these plugs in the back to the regular jacks that are already in the car, and then those power the LEDs. What do we got here? Oh yeah, one gasket. We'll get back to it. Oh, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 LEDs. That's better than I expected. That's going to be awesome. All right, well, let's check these out and see how they work. We are going to connect them to this benchtop power supply. 12 volts going here, and what do we have? We've got 3 lights. 1, 2, 3, 4. We got 4 plugs. That's 12 lights. That adds up. We now have all the lights wired up and turned on for a test. They all look good. They're running at 12 volts. I'm running through this ammeter just for a better result, more accurate result. 57.9 milliamps. That's small. We could run this directly off an Arduino. We don't even need like transistors or anything. We can run each of those LEDs off a different pin. It's under the Mac. Oh, this is going to be good. It's going to be good. The next thing to do is I have to electrically isolate each one of these so I can power them individually. And I can't get to them from the back. If I look in the back, I can see where 1, 2, 3, 4 of them are soldered in place, but I can't get to the rest of them. So I'm going to have to get this out of the case. Now I just took these screws out and these out. These are just blind holes. They do nothing. And these hold this inner piece in place. It looks like this is all glued together. I think we'll try heat. I need to get this back panel off and get access to the LEDs. I've got this propane soldering kit. They're fairly cheap. You can get them around. And it comes with this little knife blade attachment. If I look inside, I still see some liquid. So I've got, did I say propane? I hope not. Butane. So I've still got some butane in here. Let's heat this thing up like this torch. And this should heat up in just a minute. Now, melting ABS plastic is something that you don't want to breathe. So we're back upstairs in the above ground layer in the paint booth, and I'm going to use it to extract the fumes. There's better access in here than I expected. I put this tape on so I wouldn't burn the edges too much. I think I can get these individual bars out and work on them one at a time. That's going to be fantastic. That's going to be a lot easier than I expected. But I'm out of butane. So back to the below ground layer to get this. You can pick this up at like Walmart, probably most hardware stores. Just sprays down in there. You can see the liquid. Probably don't want to be smoking while you do this. We got all these pulled out. Oh, look at that. Here's the resistor on one end. And I bet that, we'll look it up later, I bet that's a full wave bridge rectifier. That's what that is. I mean, they've got red and black marked, and we know these diodes are polarity sensitive. But if you put that in there, then it doesn't matter which way it's hooked up. Like the incandescent bulbs in an automobile, at least the old ones, like was in this one, they're incandescent. So they don't care which one's positive and which one's negative. Diodes definitely do. We can test that out real quick. Let's do red to red and black to black. And what do we get? Good. We double check the lights still work. Let's switch these around. If your car happened to be wired up the other way, it wouldn't matter to the incandescent and it works. Oh, those are cute. Cute little full wave bridges and a little resistor on the end. Let's wire them up so we can control them individually. We can get our Larson scanner going. So I need a 4-wire plug. I'm going to use these because we have one ground wire and then we'll have 3 positive wires to run each of these. Well, that's harder to cut than I expected. That's a big, hefty trace right there. Well, they say always use the right tool for the right job. And I finally found the right job for this cheesy little Harbor Freight Dremel tool. Doesn't have a lot of power, but it's got enough to cut through these little copper traces. Got all 4 of them soldered up. We've got the wiring done, just finished screwing these back into place. Okay, I did some epoxy in here, just a strain relief to each of these cables so they can't get tugged on too bad. And it's time to reattach these pieces so I have the bolts to connect to. So the way I think I'm going to do that is I'm going to do a little bit of friction welding just to tack them in place. And then I'll come back and figure out what I'm going to do for the whole seam. Just chucked up a little piece of ABS filament. And we'll give this a little spin. So that should be enough to hold it in place. We've got this top half welded up fine enough using the plastic welder. We'll go back and put the bottom in. You won't get to see it anyway. It'll be up under the deck lid. It just needs to be strong enough to hold these in place, and it's strong already. I've written some quick and dirty test code to make sure the LEDs are still working now that we've got the ABS welded back together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12! We're golden! Let's look at the features. I've got some firmware written. I want to show you some cool features now and a secret one for later on. So let's assume that this is our new Cobra vehicle. Isn't that nice? And this is our brake light. And over here are our brake pedals. So we have different modes of operation for our brake. This is the first mode. Oh, look at that. The brake light comes on. That's amazing. But we have more than that. Maybe you want more than just the brake light coming on. Maybe you think you're fancy. Maybe you want something like this. Look at that. Center out. Zing, zing. That's not too bad. But we have another mode as well. Look at this mode. We have, repeated center out. Zing, zing, zing. And we have, zoom. That's stutter on, right? That'll get your attention. We've got another mode, but we're not going to show that now. But we have some off modes. Here's a new off mode. Couple of seconds. Cylon! It's still looking for trouble. You just hit the brakes, but you know there might be something else coming up. So it keeps that up for like 10 minutes, and then it shuts down. Just so that after the break, a couple of seconds to make sure everything's okay, and then on the lookout. So these are the brake modes I came up with. If you have some other ideas, put them in the comments below. Also, it stores the brake mode that I enter, writes it to EEPROM, so that whenever this thing boots back up, if I hit the reboot button here, it knows what mode it was in if it loses power. Yeah, now I'm thinking about going with remote Bluetooth control from an app from your cell phone. I did look through my code and I had this little note that, yeah, you know, there might be a DOS attack, a denial of service attack through Bluetooth to your brake light. But, you know, I'm not too worried. I mean, who would do something like that?
Oh, I know. Ask me.
Now we've added this Bluetooth module so we can control it by Bluetooth. Now we've got the Bluetooth added. Let me show you how this works. We've got a regular brake pedal, and we've downloaded a free Bluetooth terminal, BT terminal free. So we can change brake modes. We can change it all from here. So maybe instead of this brake mode, we want the next brake mode. We send it, and oh, look, we get center out. So the modes, the way that I have them set is that the different brake mode, Q is query, that shows me the existing. WERT are the other brake modes. Y is the special one. We won't see that till it gets on the vehicle. And then the bottom row are for the off modes. X, for instance, is Cylon mode. So we send this X for the Cylon. And after a couple seconds, we get that. Or we can turn it back off. So now we can do this from the front seat of the car. We can set the brake mode. We don't have to fiddle with anything else. Look at our fancy new brake light. Brake. And then when it's off, Cylon. Time to think about power for this brake light. I found this in my box. It's a little bitty buck converter. Written on it 2 amps, step down, output 1 to 17 volts, input 4 to 23 volts. Theoretically, you could hook that Arduino straight to a car battery. 12 volts is a little iffy on those, but it should handle it. But cars aren't really 12 volts. They're 14 volts, 15 volts with lots of ugly spikes. So I'm going to feel better about adding a step down converter. Also, the input signal. I need something that's 5 volts, and what I've got is the brake light, which is again 12, 14, 15 volts. You could try a voltage divider, but it's not very accurate. I found this in my junk bin. I think it's part of an old, maybe an old DVD player or something. But you look over here, you see that? And you see that slot cut out? So that's an opto isolator there. I'm going to pull that out and use it. That way I can run whatever voltage I want on the input, which will be that 14-ish voltage, 12-ish voltage, and run the 5 volts out to the Arduino. To desolder this opto isolator, the first thing we're going to do is add a little solder to each of the pins. That usually makes it easier to desolder. Then grab the solder sucker, pop, 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 and if you do it really nice like that one did, then you can just pull it right out. Bingo! Let's test this buck converter. We're running its input off this bench power supply at 12 volts. And then we'll turn down its output to 9 volts, which is much easier on the Arduino, especially if there's higher voltage or noise coming from the car. All right, 9 volts more or less. Of course, I'm not going to be able to load it up. Let's crank up the voltage and see if it remains sort of stable under voltage. It's supposed to be good to 23 volts. There we go, 21. Still 8.85, and down to 9, 10. Well, I'm trying to get 8, so it'll need a little room, but looks like it works with 10, 9. Yeah. Oh, this part is cool. These little rectifiers that I took out of the tail light when I was re-engineering it for the LEDs, I got to put back in line with the brake light to make sure the polarity is correct when it runs through the opto isolator that we took off of that other board, wherever it is laying around here somewhere. Oh yeah, here it is, the opto isolator. So that's cool that I get to reuse this piece. I'm glad I have it laying here. I'm going to solder our buck converter power supply to this circuit board, and I'll solder the opto isolator on here as well, and then solder them directly to the Arduino. We've got the bolts loosened up underneath. Out with the old. And you can probably see here, maybe better, how nasty and scratchy and scuffed up this is. Which is why we really needed to replace this. And in with the new. Time to mount the bracket that I 3D printed. I'll print a case for it later when I figure out exactly where I want these wires to come out. But let's add a hole or two. That looks like a pretty good place. That tape keeps it from drilling all the way out the top of the vehicle. All right, now we've got it installed. Brakes on. Look at that, like magic. Brakes off. Okay, now let's see. We bring it off the cell phone app, and look, we can pick a different mode. Let's try this one. All right, brakes on. Hey, look, it's center out. All right, and we've got another mode. Brakes on. That's the center mode. Brakes off. And then finally, one more magic setting. Here we go. That's set. Brakes on. Brakes off. And now, after the brakes off, a little bit of quiet, and there it starts the scan back and forth, Cylon style. Zoom, zoom, zoom. And don't you dare say Kit, that was a Chevrolet. Hey, this is the final secret display. This is a POV display. It's blinking a pattern. So if you actually glance up here and glance down to the ground, and you do it at the right time, you might see something. It's hard to capture in this light. I'll show you a still that I got from inside. Here's a still capture of the POV persistence of vision display. It's showing this pattern all the time. I captured it by tilting this mirror back and forth really quickly, but if you glance across it at the right time, you might see that in real life. How awesome is that? All right, well, I hope you had fun today. I sure did. Don't forget to like it, don't forget to share it with your friends, and don't forget to spend all your money on coke and strippers. Hello, I'm Monte. There goes a car. Time for a quick update. When I changed this other Arduino, I didn't program the EEPROM.